Good day, everyone. I'm an R&D engineer. I've been building features and technical solutions at Cellframe Network for quite a while now. And I thought this could be a good opportunity to run a technical blog where I review those features from the developer's perspective, which could be useful for devs and advanced users who want to understand the engineering behind the scenes and how the logic works. And for the test episode, I chose the recently released Cellframe DEX, where I developed the internal logic. To make the review more explanatory, I'll use both graphical UI and Cellframe Node command line interface. A clean setup in our testnet with 3 wallets representing the traders, with some tokens on their balances, and a trading pair with almost no history and empty order book for a cleaner view. I'm definitely not a pro narrator, but I'll try to do my best to be clear and specific. So let's not drag this out and get straight to the point. The main thing to know about this DEX. The DEX is a typical decentralized service in Cellframe ecosystem that is built fully on-chain. That means every order and every operation with an order is not just a row in a local database or an entry somewhere inside an exchange backend. It is always represented by its own transaction on the network. So let's create a couple of orders. For example, Alice sells, we start with limit orders. Alice sells some Kel at the price 4 Kel per cell, then she sells at some bigger price. And then let Ivan also sell some amount at yet more bigger price. So the orders are already on chain, by the way. Here how they look in the UI. And at the same time, an order is a transaction which can be dumped or checked in the Transaction Explorer. So what makes this transaction special? Well, it contains a so-called conditional output item. This is a native Cellframe concept and one of the central features of our UTXO model implementation. A conditional output locks value under explicit rules. This value is not assigned to a regular wallet address, as in the case of standard output. Instead, this output can be spent only by another transaction that satisfies this condition. For the DEX order, this condition describes the maker intention, what asset he offered, what he expects in return, the price, and some other optional rules under which the order can be executed. So let's check this one. Here we see that 20.0 value is locked in the output, but a regular transaction dump doesn't decode the full service-specific structure. It only shows the hints, the subtype, and the unique ID. And to unfold this condition, we should use another command, srv-dex history, using the same transaction hash. Yes, and we see just the same picture as in the UI. So this is Alice's order. She locked an amount of 20.0 Kel. In exchange, she wants cell at the price 4.0 Kel per cell. Okay. So all such conditional outputs are specific to the services they belong to. For example, here is another conditional output item for a different purpose, network fee collection. And for the DEX order, these are the rules that must be satisfied to consume this order. In the command line interface and in remote API, there are also available more advanced restrictions to set for your order. By the way, we may check them if we call help command for Cellframe DEX and filter the output by order create subcommand. So here are those arguments. Minimum field policy, for example, all or none will not permit the takers to execute your order partially, only the entire value in one trade. Or a specified minimum field percent, expiration date, and so on. So now let's proceed with purchases. So let Ivan purchase Alice's. Now let Ivan purchase Alice's order. Let's start with partial purchase. Here are 20.0 kel available, but we will buy, 15, right? And let's check this transaction. Yes, it's already accepted. So this is also, the partial purchase is also a transaction. It legally spends the conditional output, uses it as an input. And here the order did not disappear. The field part is settled and the remainder, 5.0 kel, is still locked in the output under the same DEX rules. So now let's try a full purchase, this one, and we buy the whole amount of 30.0 kel. Ivan buys from Alice. Yes, it's already passed. And this is the same transaction pattern as a partial execution, but there is no remainder left to continue. So there is no conditional output item with subtype Cellframe DEX. The funds from the output are fully consumed, so the order is closed, and the closing transaction is visible on chain. Canceling follows the very same pattern. It is not just a database delete. It is a transaction that consumes the conditional output and returns the locked value back to the seller. So let Ivan try to cancel his own order. And we'll see. A cancellation transaction on chain. So here, 40.0 kel returned back to Ivan's wallet address. And no more conditional output available for further trading. There is one more lifecycle operation that is called update. The seller should use it if he wants to change the remaining amount, either decrease it or add more funds to it. There is no UI button for that purpose, so for now I demonstrate it in the command line. To do that, we need Alice's order. Yes, it's Alice's one. Cellframe DEX order update. hidden order using the same transaction hash, wallet Alice, value. Let's specify, for example, 10.0 cal. Fee is mandatory as well. So, yeah. And yet again, this transaction will be available after it passes. Yes. So what we see here, Alice increased the locked amount to 10.0 cal on the output. So now 10.0 cal is a tradable amount. Service rules, by the way, allow updates and cancels only for the order owner, meaning the creator of that order. If I try the same operation on an order created by another wallet, the transaction must be rejected. So we may try to update the same order, but with, for example, Ivan's wallet. Okay, Ivan. It doesn't even compose. Well, if you try to forcibly create such a datum and put it into the mempool, the transaction will fail. The network will reject it. So, to summarize, order lifecycle can include 4 operations: create, purchase, partial or full, update, and cancel. And since we already accomplished 3 operations on this order, we can see them in the order details. And if we dump this order with Cellframe DEX history comment, we will see all those operations as well, aggregated to a readable form. One short note about service fees. Updating and canceling orders are not charged the DEX fee. The service fee is always paid by the buyer, so it appears only in purchase transactions where a buyer actually participates. So the common pattern is the same across the whole life cycle. The order stays as an on-chain conditional state, and every meaningful change is expressed as a transaction that the network must validate. If Ivan wants to buy an order, we can see that he is charged service fee. All right. Let's keep it here. So with that in mind, we can compare this model with other exchange designs people are already familiar with. For example, centralized exchange like Binance, Coinbase. On a CEX, the user deposits assets to the platform and must trust the platform's custody. Balances, matching, withdrawals are all handled by the exchange backend. In Cellframe DEX, you don't deposit your funds anywhere. You just lock them in an output. And the rest in order is not an internal record. It is a conditional output on the ledger. AMMs, or pool exchanges, as Uniswap or PancakeSwap, use liquidity pools, and price comes from the pool formula. Uniswap version 3 has ranges that can imitate limit orders, but they are still liquidity position inside an AMM curve. And Cellframe DEX is not pool-based. It uses explicit bids and asks. Cellframe is closer to other order book systems like DYDX, Injective, or 0x. But they use different settlement pipelines, maybe off-chain quotes or specialized subchains. And in Cellframe, the DEX is a service that can be turned on for literally any network. So we have the DEX enabled in our backbone mainnet and in this RAID and testnet. But you can enable it for any network you want in your setup. So the next important feature follows directly from this model. Every order in Cellframe DEX is effectively a limit order. The order itself, whenever you create an order, you don't ask the network to buy or sell at whatever the market gives. You always define a fixed rate as concrete exchange criteria, and you set it in your conditional output. And the market then appears organically from the order book. Many fixed rate intents form bids, asks, spreads, and available depth. But how market trading works then? Well, I implemented it with so-called matching engine. It is not another special kind of conditional output. It's a service layer above the limit orders we have just discussed. To demonstrate, I need to create more. Let Bob also sell some amount of KEL at limit order at a different price. This. And one more. Okay, it's done. So how the matching engine works? It walks the order book by the best available price, combines the orders, and stops according to the specified budget limit or a rate limit. If you don't want to purchase at a higher or at a lower rate, depending on the site. So we have 3 bids here, and the best rate is the highest rate. So let Ivan buy some tokens on market, having his budget limited with, okay, he should limit his budget. Well, let it be 9 cells. So the UI may precompute the received amount according to the visible market rate, but this value is not guaranteed to be exact. So, because not all orders in the market have this rate. But if we press buy, we will see that at this limit, we will receive a bit more. Well, let's do this. And check the transaction. Yeah, here. So 2 orders were consumed, 1 fully and 1 partially. So the matching engine selected the best bids with the higher rate, and here we can see which orders were closed, used as inputs, which orders, and here we can see which orders were closed, the hashes. Each closed order has its conditional output, and each one was consumed according to its fixed rate. The important part is that this multiple purchase is not a chain of separate transactions. All the outputs are consumed by one single transaction. So one auto purchase can take liquidity from as many suitable orders as needed within their budget and rate limits. And for both sides, the buyer and the seller, or maybe multiple sellers, it is a single action and one resulting transaction. And this is one of the convenient parts of the model. The order book can be fragmented across many small limit orders, but the buyer doesn't have to manually buy from each one. Instead, the matching engine, when you choose market trades, the matching engine builds a single combined transaction that consumes the selected orders together. So, to summarize, targeted purchases, so when we explicitly press purchase, are more natural for Cellframe DEX. I can buy from any selected order, even if that order is outside the current best market area. The trade is still valid if it satisfies the order's condition. And this is useful for real cases where you don't want automatic best price matching. For example, an OTC style deal agreed with a specific counterparty, or a public order with known terms that the buyer wants to accept explicitly. In that sense, targeted purchases are actually close to a peer-to-peer style deal, while settlement still happens through the DEX rules on-chain. And in practice, it implies that Cellframe DEX is also an on-chain peer-to-peer platform. But there is also functionality for market-style trading as well. So what else is different between targeted and market-style purchases? Since a target purchase may be outside the current best market area, it shouldn't move the candle price. Candles are built from market-satisfying trades only, so the executions that go through the market-style path and reflect current best price discovery. This keeps the chart from being distorted and biased by manually selected trades. But targeted purchases are still real trades, so they are included in the volume at every timestamp. So the split is pretty simple. Candles show the market price picture, while volume shows broader trading activity. One honest note about performance. The current DEX is actually not designed as a high-frequency trading venue, since order changes are all expressed as on-chain transactions. The speed naturally depends on block creation time. But this is not a fixed ceiling, of course, as I mentioned recently on my X. We are optimizing the consensus performance with the goal of moving toward sub-second block time in a well-connected network. And since one block can contain more than one transaction, it implies that TX acceptance time will also become less than 1 second. And that should reduce the DEX latency as well. And there is also one unpleasant but natural edge case in this model. Several transactions can land into one block, and for a short moment, the visible order book can become so-called crossed. That means the spread may become negative. This is a temporary and self-balancing phenomenon. Market-style purchases will consume such opportunities quickly, but still, for an on-chain order book, this short-lived state is possible and should be understood honestly. We can simulate the situation directly by creating an order. Okay, let Bob create an order of another side. So he will lock some amount of cell tokens at a price a bit lower than the best bid is, for example, 4.4, all right? So here it is. Now we have an ask. And let's check the spread with a special command. So DEX spread. Net kill cell Yes, we can see that the spread is now negative. The spread state crossed means that we have this situation. Now the book is crossed. This looks a bit unusual, but it's simply a result of explicit on-chain order creation. Well, the nearest market purchase will consume the best anyway. So, for example, if Alice buys this amount at the market price, okay, let her sell that 44 kil. So here, Alice got her cells on her balance now. There is one more important feature I forgot to mention about market style trading. Whenever a trader wants to buy on the market and at the same time his budget exceeds the available amount in the whole market, he can use this option to create a new order combined with his purchases in one single transaction. So, for example, Ivan uses more budget than available on market. So, 10 cells. And we can see that two orders match according to the matching engine. And there is also a leftover of 3.8 kil, which will be locked in the new conditional output and treated as a new fresh order. So let's try it. And let's check. See? So this is the leftover amount that was locked in the new conditional output. And this transaction is treated both as a new order and a purchase of two other orders that were closed. So we can check. DEX history. So here is the closing trade. And this transaction has a combined type, the market trade and at the same time the new order. So this is a very nice and useful feature when your budget exceeds, when your budget is more than the market can offer you. So you purchase all available orders on the market and at the same time you create a brand new order which can be consumed further by other counterparties. Okay. Let's buy 3 cells from it and check. So here is the sequence. Order creation was combined with market trade in one transaction, and it is further tradable as usual. All right, I think that will do for today. So we took a quick look at how the DEX is implemented in Cellframe ecosystem, how the matching engine works, and what details should be kept in mind when trading. If this format proves useful, I'll try to release more technical breakdowns like this. Thank you for your attention and see you the next time.